Anytime.
Okay. All right, so today I'm going to talk to you about the Mars Curiosity lander, its purpose, and maybe a little bit of its potential. So, I'm sure a lot of you remember a few months ago when the Mars Curiosity rover landed on the surface of Mars. On August 6th, the Curiosity ended its 7-month-long journey and landed in a place called the Gale Crater. Now, there were over 60 landing sites evaluated on Mars, but they ended up going with the Gale Crater because it was the primary goal for the environment that they wanted to study. It had to identify particular geological environments or a set of environments that would possibly support microbial life. And this is the rover. It weighs about a ton. It's got like 17 cameras, it's got a spectrometer on it, it's got some meteorology stuff on it. The suspension is pretty unique because it helped it land. It literally dropped like 100 feet out of the sky and just landed. So that's pretty neat. It's only like 4 or 5 feet tall. Without this thing, that goes up. That's retractable. But now, the Gale Crater was selected because it looked a lot like a quarry in Utah. It's called the Styx Quarry, and these two pictures are pictures of the Gale Crater. As you can see, there's a mountain. It's actually a giant circle, but there's a way out. But this is Styx Quarry. I got a picture of this strictly to show you because the Styx Quarry is a giant archaeological dig site for fossils. For paleontologists and everything. As you can see, there's a bunch of different layers, and the oldest rock is actually at the top, and just over years of wind and weather, and it's slowly been eroding, and you can find a ton of fossils in there. And NASA scientists actually hope that because of this mountain, the environments will actually be very similar. Now, the rover Curiosity has only been on Mars for about 3 months, but in that 3 months, we've made a ton of discoveries. NASA has reported that one of the major discoveries is that there's proof that there was a stream on Mars. There's an ancient stream right here, and we always thought there was water on Mars, like there was molecules in the air and everything. There's just H2O molecules floating around, but they never really had proof that there was water producing from the planet's surface, and this actually is proof because, as you can see, there's this stream, there's a path right here, and it leads to these rocks. This is just a wider angle of a different spot. Oh, that circle, it didn't explain it, but these tiny rocks actually prove that there was water on there because it's the mouth of a stream, and a lot of the rocks are small like this one. The edges are rounded to show that they're too heavy to be blown by wind, but then they're way too light just to be there naturally, and the edges aren't rough, they're not sharp, they're not jagged like you would see in gravel or anything. They're actually smooth, which indicates that they've been carried by water and ground down over time. Another major discovery was that there was another major discovery was that there are substantial amounts of methane in the air. With the two previous Mars rovers that we had sent there, they only had small amounts. They only tested the air a little bit, and what we determined is that there were massive amounts of CO2. But now that the Curiosity is there, it's got a lot more equipment, it's a lot higher grade, and we actually discovered that there are substantial amounts of methane, and what that proves is that there is a source of natural gas on the planet. So, and if any of you have taken chemistry, one of the fundamental equations that you learn is that methane, when it reacts with CO2, which the planet's covered in, or when it reacts with oxygen, it produces CO2, 1 molecule of CO2, and 2 molecules of water. So there's even more proof that there was water on Mars. So, and this is a picture of the crater, the Gale crater, and scientists say that it's remarkably close to the Gobi Desert in California, strictly because of the sand and the distant mountains. And this is actually the clearest picture that we've gotten back from Mars because it's over 130 million miles away, and it takes 7 months to get there. Alright, so the similarities between our two planets are uncanny, and one might make the assumption that one day we might be able to colonize Mars. And with that in mind, I don't want to say that we're going to do it in the next 20 years. The atmosphere is covered in CO2, and we're going a couple of minutes without oxygen, and we would just die. It's like leaving your car in the garage. When I say we're going to maybe colonize Mars, I'm talking in the 4 billion year range. Yeah, so it's a little out there. And and if you think that you could just plant a seed and let a tree grow and it could absorb the CO2 and naturally produce oxygen, that's kind of a lie, because we actually, for a plant to live, there actually needs to be water on the planet. There was water, we don't know if there's underground rivers or not. So, that won't work either. Now, even though the Mars Curiosity rover is in the early stages of its 1-year mission, the data that it has sent back has far exceeded our expectations, and hopefully the Gale crater will have even more to offer in the upcoming months. Hopefully that it will tell us that there was once life on Mars, and maybe that it will be able to sustain life in the next 4 billion years, which is actually very possible. Only time will tell.